Hello everyone and welcome to another SOLIDWORKS Tech Tip from Hawk Ridge Systems. This is Jacob Ames, Senior Applications Engineer, and in this video we'll be covering a workflow for combining native SOLIDWORKS bodies with imported mesh bodies, and then adding SOLIDWORKS features to the result. This type of workflow is most common in multi-body parts, so if you're unfamiliar with those, you'll want to see the multi-body overview video we've linked down below in the description first. Here I have a traditional SOLIDWORKS model of a seat for a unicycle. You can see a handful of features in the design tree, but there's nothing particularly special about the setup for this design, at least so far. In this scenario, I'd like to build a plastic handle into the front of the seat, and I've already got a mesh file of the handle available on my system in STL format from a 3D scan. We're going to use the insert part method to bring the mesh file into this existing design as a separate body, then combine them into one, and add some features to the result. So where do we begin? The first and most often overlooked piece of this strategy is to open the mesh file on its own first and save it as a SOLIDWORKS part document. As you can see here, if I try to use insert part directly on the STL file, SOLIDWORKS will fail to import it, and in some cases won't even provide an error message. Instead, I'll open the mesh file on its own to allow the system to parse the file and create the necessary body information. After importing a mesh file, you'll likely notice a graphics body folder in the design tree. This will be the default import mode for most users and is the fastest in terms of processing time, but in order to combine this mesh with other geometry, we'll need to turn it into a true mesh body. Expand the graphics bodies folder, right-click the body, and use the context menu to select Convert to Mesh Body. Now that the mesh is in the proper format, I can simply save the file as a SOLIDWORKS part, and it'll be ready to be inserted into another SOLIDWORKS part. Now onto the fun stuff. Back in the seat model, I'll use the Insert drop-down, then select Part, to bring the handle mesh into the seat model as a new body. You'll want to make sure the Solid Bodies checkbox is enabled here to ensure the body geometry is imported, and you might also consider enabling the checkbox for Locate Part with Move Copy Body feature if your preview doesn't appear to be in the correct position. Clicking OK places the mesh body into the design, and you can clearly see how the two bodies are intersecting one another, with the triangular display of the handle body clearly indicating that it's a mesh. Additionally, checking the Solid Bodies folder in the design tree shows that our first body, the seat, is a traditional SOLIDWORKS body, while a special mesh icon indicates that the handle body is in fact a mesh. Now we can use the Combine command, found in the Mesh Modeling tab, to add these two bodies together and combine them into one. I'll simply use the Add mode here, select both bodies, and then click OK. As you can see, only one body exists now in the Solid Bodies folder, containing the mesh icon, yet I've also retained all the edges and faces of my original SOLIDWORKS features as well. Prior to SOLIDWORKS 2022, this workflow would have required turning the original SOLIDWORKS body into a faceted mesh body as well, causing us to lose these faces, and therefore making it very difficult to add downstream features later on in the design process. Now though, I am able to add any command I'd like with the original geometry without having to roll back the design. Additionally, I can now add features that blend or interact with areas that are a mix of faceted mesh bodies and traditional geometry, such as fillets. As you can see here, the result of this fillet command adds geometry between the mesh body of the handle and the traditional body of the seat, something that would have been impossible prior to 2022. Interestingly, however, if I create a couple through holes in just the mesh portion, the result is actually two standard non-faceted SOLIDWORKS faces. So you get the best of both worlds using what is referred to as a hybrid mesh modeling approach. I encourage you to experiment with the capabilities of this workflow, as it can provide a lot of opportunity to get creative with combinations of traditional geometry and imported mesh models. Now, a couple of important things to keep in mind. Mesh files are great for many applications, primarily if you intend for your final product to be 3D printed. However, meshes are typically not suitable for use in CNC or CAM operations, and they aren't particularly compatible with SOLIDWORKS drawings, as you can't reference meshes to create dimensions or other annotations. So while this hybrid mesh modeling approach may be very valuable for some users, please proceed with caution and thoroughly test this workflow for compatibility, especially if you're working in a production environment, and also understand that there are some limitations to this strategy. All that being said, we hope you enjoyed this video, and if you did, give it a like and tell us about some of the creative ways you're planning on using mesh modeling in the comments. If you haven't already, consider subscribing to the channel for weekly tech tip videos on everything SOLIDWORKS and easy access to our huge library of other tips and tricks. Finally, if you're looking to become a true SOLIDWORKS expert, be sure to check out hawkridgesys.com for more information on the SOLIDWORKS certification program and to learn all about our professional SOLIDWORKS training opportunities. Thanks for watching, and see you next time.